How's it been so far? What was your morning like? Good? Very nice. Great to hear. We're going to jump right into this because we have one of the things about Agile camps that you'll discover is the intensity of the schedule and what pace that we go at. So we're definitely at an aggressive pace here. So Gene Kim's going to come up in just a few moments. A couple of things to ask of you is when you come back this afternoon, you're going to have like a survey. So we're going to ask you to fill that out. And also, we're going to have a time where some of the sponsors will come up here, and they're going to give a bunch of stuff away. So if you could stick around for that. And then we also have our reception tonight. So we invite you to spend some time with us. OK, so there's always that one person in your life that kind of changes the direction that you're going. Anyone have that one person? Hands up. Can you think of that one person kind of going? I had an epiphany working with a gentleman who is actually here today. We had worked together. I'd just been hired as a CIO, and we were going through some interesting times being in the financial industry. And he's my head of DevOps. And as director of DevOps, he was responsible for all infrastructure and all the things that kept our data centers running. So where's Brian Luby? Brian, can you stand? Is Brian here? No Brian? Oh no, he must be hanging out somewhere. I'm going to grab him when he comes in. And if you see Brian Luby, you just have to say, hey, you're the guy. If it wasn't for Brian, and I have to share this, I wouldn't have done a few things. One, when we were going through a set of triage with a lot of our systems, he was the first person who said, hey, we got to try out this Agile thing. He's back in, there he is. Hey, Brian, we're talking about you. Don't sit down. Come on up. So Brian became my partner in crime for all things kind of agility-minded. And he really helped me get to the next step. But the reason, come on up, Brian. I do want to introduce you. Yeah, I'm really dead serious. Dead serious. I don't typically do this, but this is important. All right, so this is Brian Luby. Brian, this is everybody. Hello. Brian's currently the vice president at Moby here in Portland. And at one time, I was the CIO, and he was a director. And we had a lot of fun working with some financial systems. So our customers were like U.S. Bank. Fannie Mae was a customer.
Fannie Mae,
so,
Goldman Sachs.
Yeah. So we had a lot of tech issues we had to deal with and a lot of compliance issues.
A lot of tech debt.
We had tech debt that you wouldn't believe. And after Brian introduced me to Agile, we got trained by Jeff Sutherland, and that triggered a whole new set of thinking. In fact, this Agile camp actually wouldn't be here if it wasn't for you dropping that one little seed that one day we said, you got to try out this Agile thing. So I want to thank you for that.
Yep.
And there's another intersection. So along the way, I'm working at my desk, and we're going through a bunch of audit stuff, as you can imagine. And this book lands up on my desk. It was a black and yellow book. It's called the Visible Ops Handbook. And it introduced me to an idea about ITIL. And for those of you who don't know about ITIL, it's just kind of a set of practices for technology. And I flipped through it, and it really helped me to think, hey, we could take this Agile thing a little bit further. Fast forward several years later, I'm at a conference like this, and there's this guy who gets on stage, and I'm supposed to speak after him, and he starts talking about how he wrote the Visible Ops Handbook. I'm like, this guy's awesome. That was Gene. I'm like, this guy, he was part of this, and it was because of Brian. He sat on my desk, and now, can you see what's happening here? It's the networking, right? And then Gene starts talking about this other company that he founded, Tripwire. And he was the founder and CTO, and I'm like, wow, that's the second time. Gene kind of saved us from a couple of audits.
Oh, yeah.
We had some audit issues, right?
Yes.
Pretty bad. So we were able to get through a lot of audit issues thanks to Gene. So, and then the third thing that happened was reading the Phoenix Project. Anybody read the Phoenix Project? Fans? Of you who read the Phoenix Project, which character were you? Because we all felt that we were the character. Brent. Do you remember that? Well, that really helped a lot of folks that we're working with today understand what DevOps means. And reading that book and having worked with Brian and seeing the intersections, it really is definitely true. And recently, Gene has written the DevOps Handbook, and he co-wrote with Jez Humble, and that's available to you for your reading. And for me, most of all that's coming up is Gene's conference. Thank you, Brian. So hey, Brian. So now you're sitting out there, and you're about to listen to Gene, and my challenge to you is who can you be that one seed for? Who could you repeat back what you're going to learn to your team that could trigger a series of events that you would have no idea fast forward 6 years from now? With that, Gene Kim.
Thanks, Stacy. As Stacy mentioned, I've had the privilege of studying high-performing technology organizations. So that was a journey that started back when I was a CTO and founder of a company here in Portland called Tripwire. And our goal was always to understand how did these amazing organizations do what they do, so that we could understand how other organizations could replicate their amazing outcomes. And so just briefly, these high performers were those organizations that had the best project due date performance and development. They had the best they had the best operational stability and reliability in ops. They had the best posture, security, and compliance. And so the goal was always understand how other organizations could replicate those outcomes. And so in that 18-year journey, you can imagine there were many surprises, but by far the biggest surprise was how it took me into the middle of the DevOps movement, which I think is urgent and important. In fact, I think the last time that we've seen any industry revolutionized and disrupted to the extent that our industry is being disrupted today was probably manufacturing in the 1980s, when it was revolutionized through the application of the lean principles. So, and I think that's exactly what DevOps is. You take those same lean principles, apply it to the technology value stream, and you end up with these emergent patterns and behaviors that allow organizations to do tens, hundreds, thousands of deployments per day while preserving world-class reliability, security, and stability. And that's something that we didn't even think possible 5 or 10 years ago. And so the Phoenix Project came out in 2013, and I cannot overstate how much I've learned even since the Phoenix Project came out. So what I want to do in the next 45 minutes or so is share my top 6 learnings. But before I go there, I want to just briefly talk about why I think DevOps is so important. And I think it's because of this notion of this downward spiral. What the Phoenix Project was really trying to design to evoke was this feeling like, oh my gosh, what's happening to the people in the book is actually happening to us. Right? And it happens regardless of what kind of organization we're operating in, regardless of what financial vertical, independent company size, even profit, not-for-profit. Left unchecked without something like DevOps leads to horrendous outcomes, regardless of whether you're a developer, tester, operations, or information security. And ultimately, the organization harmed is the organization that we all serve. And I think one of the best verbalizations of why this downward spiral occurs was coined by Ward Cunningham about 12 years ago, also a Portland resident. And he called it technical debt. And specifically, he defined technical debt as that which we feel the next time that we want to make a change. Right? In my mind, it is almost this poetic phrase because it invokes, for me, this image. It is the accumulation of all the crap that we have allowed into our own data centers, each time made with the promise that we're going to fix it when we have a little bit more time. But just the way that human nature works, the way that life works in general, is that there's never enough time. So this, although bad, is not as what it inevitably becomes, which is this. Right? And so what are the behaviors that we do in our daily work that causes technical debt to accrue? It happens every time that we take shortcuts in projects and push it into production, right? Because someone has to operate and maintain it, potentially for years or decades. It happens every time we manually do a deployment. It happens every time we manually configure an environment. It happens every time that we take, we write code that doesn't have automated testing. So those are all downward spirals. But would you believe that there's a more destructive downward spiral that exists, but the problem is it's almost invisible. And and that's what makes it even more destructive, right, is that deployments start taking longer. So think of a friend who's been associated with an application that would take a minute to deploy, it takes an hour, a day, a weekend, maybe even a week. And it certainly doesn't end there. One of the most formative experiences for me was around 2007, where I got to watch a team supporting a $3 billion a year display ad search business, and their deployments would take 6 weeks. Why would it take 6 weeks? Because there were 1,300 manual, very tedious, extremely error-prone steps that would tie up 300 to 400 people, right? And so when deployments are that problematic, that's what sets the stage for the intertribal warfare that can exist between dev, QA, and operations. So here's our friendly developer, right? They check their code into the repo at 5 p.m. They're out celebrating, buying rounds for each other at the Mcmann down the road, right? Not realizing they've set the entire data center on fire, right? And now ops, QA, information security, and soon intoxicated developers have to work all weekends to try to figure out how to get things running before customers notice on Monday morning. And so, what we were trying to show here is that when this happens, no one is achieving their goals. Features are never making it to market. Deployments are taking longer and they can become more problematic. We have an ever-increasing number of 7 outages happening in production. Operations and QA becomes increasingly buried in unplanned work and increasingly unable to pay down technical debt when everybody knows that that's how we can actually help our organizations win in the marketplace. And it doesn't matter, this affects us regardless of whether we are in operations, whether we are a developer, whether we are a product owner or a product manager, or even information security, right? And so we know there's a better way. And we call that very broadly DevOps principles and practices. So the first thing I want to share with you that I wish I had learned before the Phoenix project came out is to what extent DevOps principles and patterns create amazing business outcomes. And this is based on work that I did with Jez Humble, Dr. Nicole Forsgren, and in conjunction with Puppet Labs for over 4 years. We've now benchmarked over 28,000 respondents trying to figure out what does high performance look like and what are the behaviors, cultural norms, and technical practices that predict performance. And for sure, what we found was that high performers are massively outperforming their non-high performing peers. So on one dimension of performance is agility and throughput. We found that high performers are performing 46 times more frequent deployments. So that could be deployments of code or changes to the environment. And not only are they deploying more frequently, they can do it far faster. In other words, how quickly can they go from changes committed to version control through testing, through deployment, so it's actually running successfully in production and customers are getting value. High performers, we found now decisively this year, with a sample size of about 6,000, is 1 hour or less, whereas lower performers might require weeks, months, or even quarters to get into production. So, so for 4 years in a row now, we found this very decisive performance difference between high and low. But it's not just about how much work they get done, it's also about outcomes. When high performers do a production deployment, they're 1/5 as likely to have those blow up in production, resulting in a 7 outage, a service impairment, a security breach, or a compliance failure. And when something does go wrong, high performance can fix those issues 100 times more quickly. In other words, the mean time to restore service is 100 times faster. And so again, this is very decisive 4 years in a row. The only way that we can get these sort of reliability profiles is to do smaller deployments more frequently. So another dimension of quality we found for 2 years in a row is that because high performers are integrating information security objectives into everyone's daily work, they're spending 1/2 the amount of time remediating security issues. And because they're doing a better job controlling unplanned work, they're able to deploy nearly 1/3 more time on planned work. So that's the more strategic activities, right, versus the much lower value activities like firefighting and so forth. So we call that group of performance metrics IT performance. About 3 years ago, we started looking at this other dimension, which is organizational performance. We found that high performers, they were twice as likely to exceed profitability, market share, and productivity goals. And for 2 years, people have been asking, well, what if we were a not-for-profit? What if we were a government agency, a military service, a charity? And so for the first year this year, we asked, if you're a not-for-profit, a certain set of other questions. And we found the same dimension of performance as well. They were twice as likely to achieve organization and mission goals, regardless of whether they find it as customer satisfaction, quantity, or quality. And so I think what this shows us, without doubt, is that when mission achievement requires technology, DevOps helps with the achievements of those objectives. We found, again, another indicator of organizational performance is that in high performers, employees were twice as likely to recommend their organizations as a great place to work to their friends, family, and colleagues. And we even found that in high performers, that gave us a stock ticker symbol with a sample size of over 1,000, High performers had 50% higher market cap growth over 3 years. Right, and I'll be honest, I'll be the first to admit that this is a preposterous finding. Right, essentially what this is suggesting is that how a developer or an ops person, how they do their daily work could impact profitability or even be visible in share price, which I think is a lot to ask anyone to believe. But if we believe that how most organizations these days, how they acquire their customers and how we deliver value to those customers are reliant upon the work that we do every day, maybe being 3 orders of magnitude faster than our competitors, we'll create decisive winners and losers in the marketplace. And that I find very, very easy to believe and very compelling. So there's one other thing that I've come to understand in terms of metrics, which is this notion of deploys per day. Deeply embedded in the DevOps community is this notion of deploys per day. Even the seminal presentation given by John Allspaw and Paul Hammond in 2009 was about doing 10 deploys a day, every day, at their daily work at Flickr. And so these days, 10 deploys a day is not considered so awesome, right? We consider that in the research circles to be, table stakes. In fact, Amazon went on record saying inside Amazon engineering, they're doing not 10 deploys a day, but 136,000 deployments per day, right? So that's kind of interesting, but why do you see this ever-increasing number of deployments per day? And we started to suspect that deploys per day is maybe hiding an even more important and interesting metric, which is deploys per day per developer. And so 3 years ago, we tested this in the State of DevOps report. What we found was astonishing. We found that on this y-axis is deploys per day. On the x-axis is the number of developers. And what we found in low performers, as you increase the number of developers, deploys per day goes down. In the medium performers, deploys per day remains constant as you increase the number of developers. But in the high performers, as you increase the number of developers per day, increase the number of developers, deploys per day goes up linearly. And so what this shows us is that under certain conditions, with the right architecture, with the right technical practices, with the right cultural norms, we can actually scale developer productivity linearly as we increase the number of developers. Right? This is very unlike how most of us were trained. In Frederick's book's amazing book, the mythical man month, right? He really explained our common experience is that in general, when we double the number of developers, we double the code integration effort, we double the test effort, and we double the effort required to get value to customers. So this shows us that under certain conditions, we can actually break the mythical man month and scale developer productivity linearly, even as we get to tens of thousands of developers. So, and I think what this shows is another dimension of what we want to achieve in DevOps, is the opposite of technical debt, right, is to enable small teams to work independently, to be able to independently develop, test, and deploy value to customers without having to communicate and coordinate with tens, hundreds, or even thousands of other engineers. And I think the reason why that's important is that it allows us to use every miracle that technology enables us to achieve safely, quickly, reliably all the goals, dreams, and aspirations of the organizations that we serve. In fact, a very recent aha moment for me is, let's put this into context. Right? Pinterest was bought by Facebook for $1 billion. That was 10 engineers. Pokemon Go was the fastest property to 1 billion users. That was written by 25 engineers. Right? So I think the goal of DevOps is to enable 25 engineers, put them into any modern technology organization, right, and enable those type of amazing business outcomes. So the surprise number one is certainly how much business value DevOps can create. Surprise number two is that DevOps is as good for operations as it is for development. It's now 2017, and one of my favorite case studies of how good is still the Facebook chat launch study that happened in 2008. So some of you might roll your eyes saying, it's 2008, it's 9 years old, doesn't sound very relevant. And some of you might be saying, a chat server, right? That sounds pretty trivial, right? Undergraduates write chat servers as typically in the sophomore year in computer science, and both of those things are true. But what you might not know is that chat is inherently an order n cubed algorithm. The chat project at Facebook was considered to be the largest technical undertaking in their entire history. It was their largest project team. It took them 1 year for them to design, deliver, and actually release to customers. So how did they use that year? Every day, as soon as they created the chat team, they would start working and check code into a source code repository, and whatever was in source code in the repo in trunk was silently migrated to production at least once per day. So 2 p.m. Pacific time, they would take whatever's in trunk and migrate into production without causing chaos and disruption. The second technical practice I found astonishing is that for the vast majority of that year, they were using every active browser user session as a test harness. In other words, whenever someone logged into Facebook on a browser, they would actually send invisible test chat messages to the still invisible chat services in their data centers. And the reason they did that was so they could simulate production-like loads, right? And so the end result is 1 year after they started the project, they launched and announced the availability of chat, and they went from 0 users to 70 million users overnight without a hitch, right? How? They were able to test in production for nearly a year, right? And having come from development, if you had told me 5 years ago, is it ever okay for a developer to test in production? I would have said, absolutely not, right? You've seen what I've seen be put in production. You would say, no, thank you. But it is a game changer to be able to test under production-like loads and be able to detect performance issues at the earliest stages of the project. But let's go to the notion of the other technical practice, the notion of a daily deployment. They would deploy not at midnight on Friday and work all weekend. They would deploy at 2 p.m. Pacific time. So even if the worst things happened, they could either roll back or they could escalate to everybody in the office, right, because they're already there, right? And just to show you why I think that's so important, this quote comes from Nathan Shimmick. He said, as a lifelong ops practitioner myself, I know that we need DevOps to make our work humane. In the course of my career, I've worked on every holiday, on my birthday, even worse, on my spouse's birthday, and even on the day my son was born. And I think some of you might have friends who, out of a sense of duty or obligation, have had to do the same thing. And I think maybe some of you are like me, where you have been complicit in creating these inhumane work systems that have forced people to do this. Have to work for 2 weeks, around the clock to get things running. And I think the reason why DevOps has so much significance to me and so many of us is that we know there's a better way. And we are running out of excuses to put that better way into place. But it's not just for operations. In fact, so lest you think that this is only possible for open source hippie companies like Facebook, one of my favorite case studies that you should be aware of is from CSG. So CSG is the largest bill printing company in the US. So if you get a paper bill from a telephone company, a cable company, satellite company, chances are it comes from one of 2 bill printing plants in the US. And so the focus of their transformation was the bill printing application. And in my mind, this is one of the pathological worst cases of what you should be doing DevOps on. It runs on 20 different technology stacks, including mainframe vSAM databases, there's mainframe assembler code, J2EE, Oracle, .NET, SQL servers, you name it, it's in there. Oh, and it even runs on 136,000 thick clients that are run by the CSRs inside of their customers, like Comcast and Time Warner Cable and so forth. So by the way, what this means is every time they do a release, it requires 20 synchronized releases on 20 different technology stacks. So they did a couple things. One is they went from doing 2 releases a year to 4, but it was predicated on the notion of doing a daily deployment. So every day, they created a new team that was responsible for doing a deployment into a UAT environment. And so within a year, here were the results. When they did a production release to customers, incident count went down by 90%. Mean time to repair went down by 98%. But for me, what was most interesting is that code deployment lead time went from 2 weeks down to a day. So in other words, when they started a release, you would have a team trapped in a war room and panicking, right? Because things are going wrong. They're having live site incidents. And they would probably have executives coming in every hour saying, are we done yet? To which they would have to honestly respond, no, we're not done yet. We have 13 more days to go, right? 13 days of that by a year later, the release was actually finished by 1 p.m. Or maybe to be more precise, all the release work was done by 1 p.m. They're playing Xbox and they're just waiting for customer acceptance. So my point is, if you can do it for this, what I would consider to be a pathological worst case architecture, my claim is that you really can do this for anything. These principles and patterns transcend the technology that they run on. And so it's not just great for operations, it's also great for developers, but maybe in a way that you wouldn't expect. Patrick Lightbody, by the way, also here in Portland. In 2011, he said, we found that when we woke up developers at 2 a.m., defects got fixed faster than ever. And Werner Vogels at Amazon says it even more succinctly, if you help build it, you must help run it. And so I'm aware that jackasses like me showing off jackass slides like this is mobilizing, most likely, an entire generation of developers to hate DevOps, right? They see Stacy coming down the hall and they will sabotage every DevOps initiative they see because they would say, we did not become developers to wear a pager. Pagers are for ops people. In fact, the whole reason they became ops people is because they like pagers. And so that is, there's an internal consistency to that logic, but I think there is a more compelling narrative, and that comes from Tim Tischler, who many years was here at Nike leading the DevOps initiative. And he said something that I'll never forget. He said, as a developer, the most satisfying point of my career was when I got to write the code, when I got to test it myself, when I got to push it into production myself, when I got to see my happy customers, thanking me when it worked, and when I could see their angry, shaking fists when it didn't work, and when I could fix it myself. He said, the point is I could have fixed it faster, but the more important thing is I would have learned something, right? I would learn what not to do the next time around so I wouldn't make the same mistake again. But then he went on to say something that I thought about for months. He said, our inability to test our own code, push our own code into production, and fix our own code has diminished over the last decade. And maybe thanks to security and compliance and ITIL, of which I'm definitely a part of those movements. And I think he said, and that's taken almost all the joy out of development work. And oddly enough, putting developers on page rotation and allowing them to self-test, self-fix, paradoxically, can bring joy back, but it also increases, all the organizational outcomes that we want. So, and it's actually safer than we think. In fact, it's a lot safer than we think. So it's not just great for operations, it's also great for developers. And I think this really goes to show that it's not the world of dev versus ops anymore. It really is fellow engineers working towards a common objective. And for ops people in the room, I think we can't ignore the fact that increasingly we all are using development philosophies, development practices, maybe even development tools, right? Because we're all fellow engineers, and engineers in the same value stream, there's a tremendous value in using the same tools. So, surprise number one was about the business value that DevOps can create. Surprise number two was about how great DevOps is for ops and dev. And surprise number three is this. There's a metric that looks very tactical, but I have no doubt that it is one of the most strategic measurements of any technology organization, and that's code deployment lead time. So, I had mentioned that deploys per day is kind of almost baked into the DevOps community. But if you ask someone in manufacturing what is their favorite metric, they wouldn't say deploys per day. They would say it's lead time. And would you believe that there is this deeply held belief that goes back almost 50, 60 years, where they would say lead time is the most accurate predictor of not only internal quality, it's also an external satisfaction, external customer satisfaction, and even employee happiness. And what we found in our benchmarking work, spanning 28,000 respondents, is that lead time has those almost magical predictors in our work as well. And so in their world, they would probably measure it as, for the Nike folks, right, but probably for like when they order something from us to when they actually receive something from us, right? That's probably maybe the lead time they would look at. Or maybe if they're in manufacturing, they would say, when can we go from work being initiated from raw materials at one end of the plant to finished goods, on the loading docks on the way to the customer. So in our world, we specifically focus on how quickly can we go from a change being put into version control through testing, through deployment, so it's actually running production successfully. And so that might beg the question, why do we start the lead time clock at version control? Why don't we start it earlier when, for example, dev accepts work to go into implementation, or when an idea is first conceived? And so I think those are also valid lead time measures. But the reason we look at the point of version control is that we believe that's the dividing line between two very different parts of the value stream. So everything to the left of things being put into version control is design and development. So in design and development, the lead times are pretty long, right? It's usually not measured in minutes or hours. It's probably weeks, months, or quarters. Like Facebook Chat took them 1 year for them to design and develop. Often we're doing work for the first time, maybe never again to be repeated, right? So it means that the lead times are highly variable and uncertain. So that's design and development. But everything to the right of things put into version control is testing and operations. And there we want the exact opposite characteristics. We want tests and deployments to happen quickly. We want it to happen repeatedly. We want them to be automated, so they're the same time every time. In fact, we want to be doing them all the time. And so I'm not suggesting that testing happens only after design and development are complete. In fact, with things like test-driven development, things like pairing dev and QA, we're actually writing a test probably even before the first line of code is even written. So what's magical about the code deployment lead time is that it simultaneously predicts the effectiveness of testing and operations, but it also predicts how quickly can we create feedback for developers. In other words, now if I'm a developer and I make a mistake and I check into version control, and my first opportunity to find the error is 9 months later during integration testing, then the link between cause and effect has almost surely been lost, right? This is where it's not only, was it my change that created the error, or was it the 10,000 other changes, that are being integrated together, right? So cause and effect has almost been lost, but our ability to learn from that mistake to, stop us from making the same mistake tomorrow is also significantly diminished. So in the ideal, what do we want? The instant when I check my change in the version control, automated testing should kick in immediately, and I should know about that error within minutes, worst case hours, right? So code deployment lead time predicts how quickly can developers learn from their mistakes. It also predicts how quickly can we learn from customers, right? Ideally, we want to learn from relentless experimentation, hypothesis-driven development, A/B testing, right? If we only can deploy code twice a year because our code deployment lead time is 6 months, we are not learning very much from customers, right? So our goal is to outlearn the competition. And you're going to hear so much from Mr. Sheridan about the great work that he's done over the last decade. So it turns out all these metrics, code deployment lead time, deployment frequency, mean time to prepare, technical practices, you can predict almost all of that by just asking one question. And it is this: on a scale of 1 to 7, to what degree do we fear doing deployments? Right, 1 is we have no fear. We do them all the time. 7 is we have existential fear of doing deployments, and that's why we would do deployments never, right? So that's certainly one thing that I wish we had learned before the Phoenix project came out. Surprise number 4. Let's go. 1 was business value. 2 was DevOps is great for dev and ops. 3 was code deployment lead time. And let's go to surprise number 4. Surprise number 4 is the surprising implications of Conway's law. So it was my observation that around 2012, you couldn't go to any sort of DevOps meetup or Agile meetup without someone mentioning Conway's law. And I quickly learned what Conway's law was, but if I were honest, I wouldn't be able to repeat back to you how that informs how we design and execute our daily work. So here's what I learned, right? Conway's law is most famously interpreted by Eric Raymond. He said if you have 4 groups working on a compiler, you will have a 4-pass compiler. And this is actually based on a series of very famous experiments that Dr. Melvin Conway did back in 1968. So after a couple of times of seeing this, I certainly knew this. But again, how that affected how we work in large, complex organizations, it was not quite clear to me. But it was made clear after I saw this case study about the birth and death of something called Sprouter at Etsy. And so this is really a story about how engineers work together to create value for customers. So back in 2008, in the bad old days of Etsy, 2 teams would have to work together to create value for customers. The devs would have to work on the front end in PHP, and the DBAs would have to work on the back end, changing the stored procedures in Postgres. And so the feeling then was like, that's a big problem, right? Because now we have to have 2 teams who have to communicate, coordinate, prioritize, sequence, marshal, and so forth, right? So their goal was to decouple those teams. And they did it by creating something called Sprouter. This is short for Stored Procedure Router that would sit in the middle of the devs and DBAs. And the idea was they would work independently, and then they would meet in the middle. And as Ian Malpass said from Etsy, he said this required a degree of synchronization and coordination that was rarely achieved, to the point where almost every deployment became a mini outage. And so what Conway's law suggests is that it would almost predict this, right? As we went from 2 teams working together to 3 teams, the amount of communication and coordination prioritization went up, right? And that means lead times went up and deployment outcomes would go down. Right, so as part of the great transformation of and rebirth of an engineering culture at Etsy, their goal was to kill Sprouter. Right, their goal was to fully enable developers to make all the changes in one area without having to be dependent upon any other teams. And they did this through object relational models. Right, the goal was to make it so they wouldn't have to work with any other teams, to work independently. And as you might not find surprising, right, as you do that, they found wherever they replaced Sprouter in areas of the code deployment lead times went down, and production outcomes went way, way up. And this is because Conway's law would predict this as well. We go from 3 teams having to communicate, coordinate, prioritize, marshal, sequence, and so forth, to no one having to sequence, coordinate. All the communication is happening within the team. So I think this really shows kind of this DevOps ideal where small teams are independently able to create value, right, without having to communicate, coordinate, and synchronize with other teams. And so the lesson for me was that it's not enough to shuffle teams around on the org chart, right, you also have to have a software architecture that's congruent, that enables this different way of working. So in many large complex organizations, right, it's not one team working independently. To get anything done requires 47 different teams, right? You need the J2EE team and the middleware team and the firewall team and the stored procedures, blah, 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 right? And it takes 47 different handoffs, maybe hundreds of steps, and it's no wonder, right, that lead times are measured not in minutes, but in weeks, months, or quarters. So the goal is how do we create an architecture that fully enables these teams to work independently? And that's where I think the notion of development platforms are so important. Cloud environments that are available on demand, testing on demand, right? These are the practices and the architecture that enable these type of work patterns. In fact, in this year's State of DevOps report, we found that architecture was one of the top predictors of performance. And in fact, we found that architecture was a stronger predictor of performance than even automated testing or automated deployments. So here are the architectural characteristics that we're looking for. To what extent can teams make large-scale changes to their parts of the system without permission from anybody else? To what extent can they do their work without having to communicate and coordinate with lots of other people outside their teams? To what extent can they deploy and release their parts of their service on demand without other dependent services? To what extent can they do testing on demand, right? Can they test what they need to test without the need of an integration test environment, of which there are never enough, right? And no one cleans them up, right? They never match production, right? This creates all sorts of bad things, right? And so it turns out these are the architectural characteristics that best predict continuous delivery, as well as all the organizational outcomes and IT performance outcomes. By the way, this is very different than the way I was trained. When I was at Tripwire, we were trained it was always safe to ignore architects, right? The reason is that they lived in their ivory tower, right? They would only come out once a year. They would publish one PowerPoint slide, and then they would go back to their ivory tower, never to be seen for another year, right? And that was just another way of saying they didn't impact how daily work was performed. But what the benchmarking shows is that architecture is actually one of the most powerful ways it affects how teams work. It affects productivity, happiness, joy, and ability to win in the marketplace. I have 4 minutes. Let me go to the last surprise, which has been my field of study now for about 4 years. And it's not about the unicorns of Google, Amazon, Facebook, Netflix. It is really about horses. Large, complex organizations that have been around for decades or even centuries who are achieving the same sort of organizational outcomes that we've typically only associated with unicorns. So let me just flip ahead. Are you getting all this? And the slides will all be available. Okay, surprise number 6, right, is DevOps is as much for the unicorns as it is for horses as well. So one of the ways that I've learned about this is I've been running a conference that Stacy alluded to, which is the DevOps Enterprise Summit. And the goal was to have a conference for horses by horses. In fact, in the early years, there were no unicorns allowed. And what we wanted to do was have technology leaders who are driving DevOps transformations in some of the largest brands in every industry vertical to share their experience reports. So experience reports are a very specific format, right? 30 minutes. Tell me about the industry that you compete in. Tell me about your organization and where you fit in. What business problem did you try to solve? Where did you start and why? What did you do? What were your outcomes? What did you learn? What problems still remain? And over the years, we've had over 250 organizations share their stories. And at this point, I have no doubt that the DevOps principles and practices that were being used in Google, Amazon, and Facebook, they are as applicable, even maybe more applicable to large, complex organizations. So what I want to do is share with you a couple of my favorite case studies to arm you with patterns to potentially follow. And then I'll share you a learning about leadership. So Heather Mcmann, for years we followed her, and she was a senior director of development at Target. And the business problem that she wanted to solve was this. Every time that a dev team wanted access to a system of record, they would have to often wait 6 to 9 months for them to create the point-to-point integration, right? And so this was the biggest bottleneck to business outcomes. And so they created a next generation service called API enablement. So they took all that information from 60 to 120 systems of record, put it into Cassandra and Redis and all these exotic technologies. But more importantly, they had versioned APIs. So any team any one of the 2,000 engineers at Target could use that API to add, change, remove product catalog, store information, orders, cross shipments, any of those things on demand without having to wait 6 to 9 months. So they went on record saying that that capability enabled 53 different business initiatives over 3 years. Her team doubled in size year over year for 4 years in a row, just showing how strategic they viewed that capability. The Pinterest integration, ship to store, all sorts of things that you need as a retailer to compete against Amazon. A lot of it was enabled by this initiative. At Capital One, by the way, it's great to see Capital One here. Toprata Pal, he was the first technical fellow at Capital One. Now he's one of 44. They've created a individual contributor career track, so that architects can advance, right, and be, that you can actually advance without turning into a manager. They created a shared service that allows teams across the Capital One enterprise to do deployments safely and securely and reliably, with lead times not measured in months but in minutes. Gary Groover talked about at Macy's. They went from doing 1,500 manual tests every 10 days to now doing hundreds of thousands of automated tests daily. At Disney, Jason Cox described how he's over the years embedded hundreds of ops engineers directly into dev teams across all the various lines of business at Disney, helping elevate those teams to be as productive as if they were working at a Google, Amazon, or Facebook. Nationwide Insurance, they didn't start their transformation in a peripheral application. They started at the core. They started with the state pension retirements application fund, of which they were already the market segment leader. Raytheon, Terry Poss described how they transformed the ground control systems that control satellites in space, right, reducing the testing and certification times from months down to a day. Courtney Kistler, when she was at Nordstrom, now she's at Starbucks, she described how in order for every technology and business executive to hit their bonuses, would require them to show a 20% lead time reduction for all customer-facing properties. And the reason why I think that's so important is it just shows how, as an example of shared outcomes that span business and technology, right? And I think that's what we all want. So there's one last thing that I want to share with you, is this other thing that we found in common across the 200 case studies that we collected over 4 years, which is this notion of courage. Each one of these technology leaders, I think, were given some degree of air cover, but I think every one of these leaders, at some point in their journey, wildly exceeded the air cover they were given, essentially putting themselves in some degree of personal jeopardy. So the question becomes, why would they do that? And I think what they all had in common was this sense of absolute clarity and conviction that the capabilities they were creating for their organizations was needed not just to win in the marketplace, but maybe even to survive in the marketplace. And for me, one of the best examples of this was when I got to follow Heather Mcmann around from Target for a couple of days. And here's something I found on her desk. It's this certificate that looks like it was printed in Print Shop Pro, like on an inkjet printer, right? And it says, Lifetime Achievement Award to Heather O'Sullivan Mcmann for annihilating TEP and LARB. Right? And so the first question is, what's TEP and LARB? And she said, TEP stands for the Technology Evaluation Process, and LARB stands for the Lead Architecture Review Board. Right? So whenever you want to do something new, something novel that's never been done before, you would have to first fill in the TEP form, which would enable you eventually to pitch the LARB meeting. So you go into a room, and there's all the ops architects on one side of the room, all the dev architects on the other, maybe the chief architects, somewhere on the side, right? And they would pepper you with questions. They would start arguing with each other, right? And then they would assign you 50 more questions, and they would say, come back next month, and maybe we'll approve your initiative. And her reaction was, no one on my team should ever have to go through this. In fact, none of the 2,000 engineers at Target should ever have to go through this. In fact, why do we even have this process? And she said no one could actually remember. She said there was this vague memory of something very, very bad, unspeakably bad, that happened 16, 20 years ago, but no one could actually remember what that was. And so because of her relentless lobbying, they actually dismantled the TEP and LARB 8 months later, earning her this incredible certificate that hangs on her desk. And so these are some of the patterns that you see in these people pioneering DevOps in large, complex organizations. And it turns out there's something to this. A friend of mine, his name is Dr. Stephen Maynor. He got his PhD in transformational leadership. And when he rattled off the qualities of transformational leaders, my jaw hit the ground because, in my mind, he listed in clinical precision all the characteristics I had seen in this population of 200 leaders. And so here's what they are. There's 5 categories. One is vision. To what extent can the leader understand where the organization is going and then get in front of it, right? Not just to make their teams relevant, but to actually help with the achievements of the biggest missions in the organization. To what extent does the leader have intellectual stimulation? In other words, relentless dissatisfaction with status quo, right? Just because we did something the same way for 20 years doesn't mean that we have to do it that way today, right? To what extent can they challenge basic assumptions of how we do work? 3 is inspirational communication. To what extent can the leader overcome maybe profound senses of fear, right? That what does this do for our careers and what happens to our department, right? Can they generate excitement, not just within their team, but can they create a coalition around them that can help them take on these very powerful incumbent systems? And then number 4 and 5 are, I would say, kind of servant leadership qualities, right? Supportive leadership and personal recognition. So maybe to oversimplify, personal recognition, supportive leadership, servant leadership. In the literature, it says, to what extent can servant leaders focus on the needs of the followers, whereas transformational leaders, they would focus equally on the needs of the organization. And so in the latest State of DevOps report, we actually asked every respondent, to what extent does your leadership exhibit these qualities? And we found that the results were off the charts. We found that transformational leaders do matter. We found that teams with the least amount of transformational characteristics were only 1/2 as likely to be high performers. So it's possible, it's just so much more difficult. And yet, there's another insight that came from the study. It says leaders don't do it alone, right? Leaders need teams. They need technical practices. They need cultural norms. They need relationships. They need all the things that leaders bring to bear, right? So as evidenced by this, you take the top 10% of teams with the highest reported transformational leadership qualities, look at their performance, and compare it to the median. They performed actually worse than the median, right? So it means that leaders hang out with a bunch of leaders, they just give PowerPoint presentations to each other, right? Leaders to get things done need great teams, and great teams need to be supported by great practices, processes, and architecture. And so if you're interested in this, there's a great diagram in the State of DevOps report that really shows the causal factors, right? Whenever you see an arrow, this is an established causal factor. So transformational leadership doesn't directly impact performance. It does it through continuous delivery, through lean product management, and so forth, right? Through architecture. So if you're interested in that, that's where to go. And why do I think this is important? It's because left unchecked without something like DevOps leads to horrendous outcomes. It doesn't matter what industry we compete in. It doesn't matter how large our organization is. It doesn't even matter whether we're profit or not for profit. Left unchecked without something like DevOps leads to horrendous outcomes. And so DevOps allows us to reverse that. By the way, the opposite of technical debt is not going to here. It is us turning this into this, right? It is leveraging all we know about architecture, technical practices, cultural norms, right, to help our organizations win in the marketplace. By the way, just so you know, this is actually a picture I took of the data at a data center in Western Virginia. This actually runs all of the .com DNS registry for VeriSign, right? So Ken Silva told me when I took this picture, this is about a $60,000 cabling job. And he said, we would never blink an eye to pay that price. He said, if you are running arguably the single point of failure for all of .com, right, you don't have cables everywhere, right? This is what it takes to deliver world-class service. And so too, if we want to build a world-class technology organization, we do all the things to manage technical debt. So all of these lessons are in the DevOps Handbook. And if you are interested in a copy of these slides, all the videos and slides from DevOps Enterprise from 2014 to this year, and a whole bunch of other stuff, all you have to do is send an email to realgenekim@sendyourslides.com. Subject line DevOps. So my recommendation, don't take a picture, don't write it down, just pick up your phone and just send an email to realgenekim@sendyourslides.com, subject line DevOps, and you'll get an automated response in a minute or two. So with that, thank you so much. And Stacy, I'm so confused. My stopwatch stopped, and I think that clock is wrong. Hopefully I'm on schedule.
You're on schedule.
Thank you.